few things that you guys learned, right? The congruency properties that you guys learned. We learned them for a reason, right? Some of you guys might comment like, when am I going to use side, side, side? Now, why is that important? The reason why we learn those things is because we have to learn how to prove certain things. We're going to be given certain statements. I know the statement that you guys see in the board is not on your worksheet. I want us to learn how to do this first, and then I'll practice a few from your worksheet. But we have to learn how to prove stuff. I know sometimes when you guys hear teachers come and say, oh, let me add 3 to both sides, or let me do this, or let me do that, every time a teacher sets a rule. I used to, when we were dealing with triangles, I used to come and say, I can mark these angles because of vertical angle theorem, such and such. The teacher always explains himself or herself. So now, when we prove things, we have to explain ourselves. Like, why do we do certain things? Like, we're going to call this a flow chart. And the way we're going to look at this, looking at mine, you're going to be given certain information. So it says prove the conjecture, the opposite sides of a quadrilateral are congruent, and the quadrilaterals of a parallelogram. I'm even given a picture there. I have that RT and WA are equal to each other. And then RW and TA are also equal to each other. Right, I have that. And then I even have a diagonal, right, a little line in between them. And then some angles numbered 1, 2, 3, and 4. And I'm given the quadrilateral WATR. Right, it's a figure with 4 sides. That's what we call quadrilateral. And we're given the WA congruent to RT and WR congruent AT. And then we have a diagonal WT. We have to prove the WATR, the quadrilateral, is a parallelogram. So we have to prove that. So, and as a matter of fact, you guys see these little boxes that I have below. Some of them are question marks. Obviously, we have to fill it in as we go. We call that the flow chart because it's a chart and it guides us. So it's the flow chart. The first thing I'm gonna start with given stuff. Right? You are given certain information, so start with the given stuff. First thing I'm gonna do, I'm gonna come and say that WA and RT are congruent. I'm gonna say WA, RT are congruent, and the reason below it is given. Alright, I'm going with the given stuff. Then I'm going to say WR, AT are congruent. And once again, the reason on that one is also given. Alright, that was on the given stuff. So you start with the given stuff. I know for triangles before, I used to tell you guys, if there's 2 triangles that share the same side, you can mark it. So I'm going to come and say WT, the segment WT is congruent to the segment WT. Right, the diagonal in between. I used to tell you guys, just mark it. It works. But the reason, the way we call it, we're going to call it reflexive. Reflexive. So on my reason why, I'm going to write reflexive. So I started with 3 things. Then I have 2 triangles are congruent to each other. Right, that's the next thing it says. So I'm just going to come and say triangle WTR is congruent to triangle TWA, and the reason, what do you guys think? Something we just learned recently. Side, side, side. Right, because they're side, side, side. Right, I know WT is not marked, but we can mark that side. So those 2 triangles are side, side, side. This is a very, very strong statement. 2 triangles being congruent is a very, very strong statement. I'm giving 6 things in there. I'm saying angle W from one triangle is congruent to angle T from the other triangle. And angle T from one triangle is congruent to angle W from the other one. And angle R is congruent to angle A. Like I said, so it's very strong. You're given the 3 angles from one triangle are congruent to the 3 angles of the other triangle. Not only that, but the 3 sides of one triangle are congruent to the 3 sides of the other triangle. So having that said, I go to question step number 5. Angle 1, I'm going to say is congruent to angle 2. from one triangle congruent to the other triangle. But the reason why, once you give this statement on number 4, once you give the two triangles our statement, all the 6 rules that I told you guys, the 3 sides and the 3 angles, we're going to say because their corresponding parts of congruent triangles are congruent. I'm going to abbreviate that with CPCTC. Corresponding parts of congruent triangles are congruent. So once you use the rule for number 4, corresponding parts for congruent triangles are congruent. Then, angle 4 is congruent to angle 3. I'm still using my statement 4. And what do you guys think the reason will be? Whenever you use a statement of a triangle, that one triangle is congruent to another triangle, and you use the statement from there, either 2 angles are congruent or 2 sides are congruent, which rule do you think I will use? CPCTC. Corresponding parts of congruent triangles are congruent. So you guys notice, I'm following along, I'm completing this. But before I continue, let's remember some rules that we learned even farther back. Remember when we used to have 2 parallel lines in the conversal? So looking at my figure, let me extend 2 sides in a conversal. So I have that angle 1 and angle 2 are congruent. Can I come and say that the segment RT is parallel to WA? Why? I'm using angles 1 and 2. Not same side here. Close, you're in the right area. Okay, so I guess let me paint this a little. So if you notice, I'm using angles 1. I'm using angles 1. Oops, not that one. Well, I guess I already put it up there. Alternate interior. Angles 1 and 2 are alternate interior. Alright, let me take those things off. But now, let me leave that conversal, but I'm going to be looking at the other 2 parallel, the other 2 lines. And I said earlier that angles 4 and 3 are congruent. And then I'm going to come and say the segment RW is parallel to the segment TA. Why? Alternate interior. Okay. Then I already have that opposite sides are parallel. I have to finish with WATR is a parallelogram. First of all, what is a parallelogram? What is it? Two sets of parallel sides, right? The never intersect, that's parallel. So parallelogram is 2 pairs of parallel sides. So I have that 2 sides are parallel, 2 sets of opposite sides are parallel. That's what a parallelogram is. Every time you give me a rule and you give me the definition of the rule, we're defining the rule. So I'm going to say that's a parallelogram because of definition of parallelogram. I'll say this is a little hard to understand. This flowchart is a little hard to understand. That's why I wanted you guys to see it first, and we'll get to work on your stuff. Let us practice with one that's a little bit easier before we get to see your stuff. So let's practice with the little one that's a little bit easier. Let's say I have that triangle there. Well, 2 triangles, triangle ABC, triangle ADC. You see some markings. We have to prove that angle B is congruent to angle D. That's what we have to prove. Alright, so first, let me come up with the flowchart we're going to need. Let's start with the given stuff. Given stuff can either say given or it can be marked. What can you see there that it was marked so we can claim it's given? Sides, which sides? BC is equal to CD. Okay, that's one given. Is there another one that was given? is congruent to AD because it was given. And then my other given, I'm going to say BC congruent to DC. All right. So those were given. Which other one? I used to say, you can say this side is equal to that. You can, if the two triangles share the side, you can mark AC is congruent to AC. Okay. And you guys notice I use the reflexive property, right? Looks the same thing. All right, so imagine the third side marked. Which triangles are congruent? ABC is congruent to ABC. And then what? Side, okay. Then angle B is congruent to angle D. Notice is my proof statement. What I needed to prove is my last statement. Why can I say, well, better yet, after you use the two triangles are congruent, and you use part of the triangle, angle B is congruent to angle D. You notice is the second letter from each. Angle B is congruent to angle D. Why? Okay, why is one angle congruent to the other? Well, what? On the previous.
Yes, all combined is 180.
A, B, and C, yes, like the previous one. But why B and D? Why is B congruent to D? We don't know that they're reflective. All right, every time, remember that I told you guys that congruent statements, the side, angle side, all those, every time we use those, we can use parts of the triangle, and we use a long rule from the previous example. I just abbreviated it. Which one was it? Corresponding parts of congruent triangles are congruent. Just abbreviate it with CPCTC. If you guys come over and misspell it, like you guys mix a few letters, as long as I know that's what you mean, I'll give it to you guys on quizzes and tests. Like, am I going to be like, oh, you forgot one letter, or you put an extra letter, or you misspell it, or whatever? As long as I understand this is the rule you meant, I'll give it to you. 7.
And it just means that all the sides are equal, right?
All the sides and all the angles. So all the sides from one triangle are congruent to the sides of the other, and all the angles congruent to the other. So that's why I said that's a very strong statement. Because you're looking at 6 things. 3 sides and 3 angles from each are congruent to the other. Alright, let's practice with your stuff now. Looking at question number 1. Alright, looking at question number 1, I have some given stuff here. FI perpendicular to IF. You guys can even see FI and IF. Let me move this to the side. Alright, so here I'm going to say FI perpendicular to IF. At the bottom I have to say Y. Why am I going to say those are parallel? Because it was given. Then, I'll come back to the arrow in a minute. Then there's another statement. Angle H is a right angle. So for my statement 2, angle H is a right angle. Why can I say that it's true? Because it was given. Always start with the given stuff, right? That's the easy part. Alright, so given. Okay, so now, look at question 1. See how from 1, it takes me to 3. That's what the arrow says. So FI is perpendicular to IS. Why can I say angle I is a right angle? Equal to H. That's what we need to prove. So if you notice, the first thing says FI, the segment FI and IS, they're perpendicular. What does perpendicular mean?
Next to each other?
No, that's adjacent.
Adjacent.
What is it? They cross at 90 degrees. And they cross at angle I, right? So angle I is 90 degrees. So now, okay, so now once again, why is angle I a right angle? Because the two lines are perpendicular, right? Remember I came in and said every time you give me a rule and tell me what the rule says, that's the definition of that rule. So I'm just going to come and say definition of perpendicular. Alright, so if you notice, statement 3 said I is a right angle. Statement 2 said H is a right angle. Can I come and say they're equal to each other?
Yes.
Right, they're both 90 degrees?
Yes.
Okay, so let me call this substitution, and I'll explain it in a minute why. Substitution. Every time you have a statement, you copy it, but you modify something to it, because that something is equal to something else, that's what we call substitution. If you notice, the statement 4 and statement 2 is pretty much the same thing. I start with angle H, I change is a right angle for angle I, because I knew angle I was also a right angle. I change something from one statement to the other, that's what we call substitution. Alright, let's take a look at example 2. Let's start with the given stuff. Why is 1 true?
It was given.
It was given. Why is 2 true?
Given.
Given. Can I put on 5, can I put proof? No. Proof is never a reason. Proof, you're telling me to prove it. So if you put proof on 5, you're basically saying, I can't do this. Go ahead and do it for me. So don't put proof, only given. Alright, so we have, for number 1, SP is perpendicular to PO. So SP and PO are perpendicular. What does perpendicular mean? They cross at 90 degrees. So can I come and say that SPO is a right angle?
Yes.
And what? Definition of perpendicular. Definition of perpendicular. Every time you give a rule and it says what the rule does, that's the definition of the rule. Let me take a look at 4. You see how it comes from 2. So for 2, I knew that PO is perpendicular to OU. Then, can I say that angle UOP is a right angle Y? Also, definition of perpendicular. Because if you notice, we have PO and OU, and then we're saying that angle UOP is 90 degrees. Definition of perpendicular. So we know that angle SPO is a right angle. We know that angle UOP is a right angle. Can we say they're equal to each other? Why? Substitution. Right, we know they're both right angles, so we're just going to let them go. We're going to call that substitution. If you don't have enough space, if you notice I was writing it right below the boxes, if the space there is too little for you, use the lines at the side. That's what those lines are there for. Right, for 1 given, for 2 given, 3, 4, and 5. Like I said, I wrote it below the box. You write it below the box or the lines. It's your call. I know below the box will be pretty small.
Leonzo?
Yes.
So supplementary is basically saying substitution.
No, supplementary means that they add up to 1/8.
Okay.
supplementary, and then, okay, so let's take a look at question number 1. Complementary means they add up to 90. Complementary is 90. Supplementary is 180. Alright, so we see angles 1 and angle 2 add up to 180. So why is reason 1 true? It was given. Alright, question number 2. It says they are supplementary. What does supplementary mean? They add up to 180. Question number 1 says they add up to 180. So why can I say that they are supplementary? Not substitution.
Because
Yes. Let's see, what was it? Definition of start with an S. Supplementary, yes. Definition of supplementary. Right? Every time you give a rule and then another statement, what the rule does, that's the definition of the rule. It doesn't matter if you tell me what the rule does and then tell me the rule, or give me the rule and then tell me what it does. Like which order that they come out, it doesn't matter. Alright, let me work one more. Take a look at this one. I'm going to say for statement 1, the measurement angle 1 plus the measurement angle 2 is equal to 90. Why is that true? It was given. Good. Then, angle 1 is complementary to angle 2.
definition complementary.
Definition of complementary, good. Complementary, okay. So, if you notice, angle 1 and angle 2, they make that angle, right? And I made it with a little box because we knew it was 90. So I made it with a little box. So angle ABD is the right angle. First of all, how did it come out with the 90? Okay, I added the two angles and adds up to 90. A rule that I haven't mentioned to you guys, I'm going to say ABD is a right angle. And the reason for that be, this rule I don't think I mentioned it to you guys before, so let me give it to you guys right now. It's going to be angle addition postulate. Angle addition postulate. Postulate is basically rule. Right? It just sounds fancy. In geometry, we like to sound fancy. So, right? Instead of next to, we say adjacent. Instead of saying rule, we use the word postulate because it makes us sound smarter. But postulate is just rule. But angle addition, I think it makes sense. I'm adding angles. Okay, so angle addition postulate. Now the last one, AB is perpendicular to BD. That segment AB, there's my segment AB, there's my segment BD. I'm saying they are perpendicular. Definition of perpendicular. Every time you tell me a rule and what the rule does, that's the definition of that rule. I'll tell you guys, this is not that simple. Proving stuff is not that simple. And we're just proving with a flowchart. Mathematics, if you guys continue math, there's many ways on how to prove things. Like the higher math you get, the more ways you learn how to prove stuff. And I'll tell you guys, it's very, very important. And as a matter of fact, probably not all the math teachers, and I'm including the teachers in this one, not all the math teachers might be that great to prove stuff. When I was studying, that was actually my strength. My strength was to prove stuff. My weakness, I'll have to admit it was statistics. The stats that we learn in high school is easy, but higher stats, that was my weakness. I admit it. But there's some other teachers that their strength was stats and their weakness was proofs. So for proofs, I'll tell you guys, I am really good at it. Like I said, that was my strength. I know it's not simple. It's not simple, and I admit it's not simple. That's why we're gonna do it today and tomorrow. If you guys don't quite get it today, I hope you guys do get it tomorrow. If not, on Thursday, we'll review the whole unit, including one flow chart, because the test on Friday will have a flow chart. So make sure you're good at it. Yes.
I don't understand what you fucking do with the angle addition
Angle addition postulate. Because the way we came out with 90, because we added the angles, right? Angle 1 and angle 2. So every time we add angles, we call that angle addition postulate. Right? You're adding angles.
So you put that every time something like that comes up?
If you're adding angles, yes. If you're adding angles, like the postulate is just fancy word for rule. Let me take roll really quick. All right, any questions? What was it? That will be. You have questions, Stephen?
Yeah, for worksheet C, number 1.
Worksheet C, number 1. You're looking at this one?
Yes.
Okay.
That was it means, that's the definition of supplementary, right?
Definition of supplementary means that we're saying that two angles add up to 180.
Yes.
That will be definition of supplementary. So I guess for this one, let's work it out. Question, statement number 1, angle 1 is supplementary to angle 2. Why is that? Right, I don't know that they add up to 1. Well, it's the definition of supplementary. But how do you know they add up to 180?
Because
The angles divided to
But angle 1 is narrower. So how do you know they add up to 180? How do you know angle 1 and angle 2? Because what? Because it's a line. Right? They add up to a line. So remember how we used to call this linear pair? But angle 1 is supplementary to angle 2, linear pair. Alright. Why is angle 3 supplementary to angle 4? Same thing. Right? Different picture, but same rule. Why is angle 1 congruent to angle 4? It was given. Alright. So now I'm going to say angle 2 is congruent to angle 3. Because if you notice, I have that angle 1 plus angle 2 is 180. I also have that angle 3 plus angle 4 is 180. And then I have that angle 1 is equal to angle 4. So I can come and say this is the same thing. Why is angle 2 congruent to angle 3? I heard it earlier here. I never said yes or no, and I just heard it somewhere over here. Substitution. Alright, so substitution for that one. And I'll admit it, from the whole unit, this is the hardest part. Make sure you guys practice it really good. If you guys need tutoring, you know it's Tuesday, Wednesday, and Thursday for help. I'll be there today. But Wednesday, Thursday, you guys can still show up for help. I won't be there, but there's somebody there.